We've been trying to show throughout this series how Deleuze and Guattari, in A Thousand Plateaus especially, offer some specific examples to discuss, and then they work towards a more general philosophical notion to explain these examples. And we've been suggesting that you might operate in a similar way, looking at the examples and then trying to think what they have in common for yourself and what some theoretical and political implications might arise. The second stage takes longer unless you are already a philosopher, and much will depend anyway on what you are reading Deleuze and Guattari for, how much time and effort you can devote to them. We're offering only pretty basic summaries here, and there's a bit of a broader discussion on my website. In this plateau, we are told early on that smooth space rarely appears in a pure form and is usually mixed with striations, that is, lines that structure and divide up space, things like boundaries, parallel lines or grids. This will eventually lead to an attempt to get to pure general definition. Only proper philosophical notions will be pure, able to specify a space without any striations at all. And we have to philosophize here because normal everyday conceptions of smooth space are too limited and will still contain actual striations, boundaries, lines or channels. To take an easy example based on my own work, we might think we're engaging in uninhibited action free of all constraint when we are alone or on holiday, or working unsupervised in the security of our own classroom or whatever. But the point is that none of these activities really are free of striation, direction, control or channeling, which often happens at an unconscious level. So people on holiday still display conventional views of gender, for example. Sometimes they show racism or nationalism. They can demonstrate their social superiority by heading for the local high culture, or deliberately ignore it to have a laugh with their mates. We know that for Deleuze and Guattari, domination is widespread and subtle, and we saw this with the comments about subjectification and significance, especially in the video on the body without organs. So let's look at some of the actual examples of smooth and striated space in this plateau. We begin with a reference back to the issue of nomads versus the settled or sedentary societies, which was developed in earlier plateau. Nomads live in relatively unstriated spaces like deserts and unworked land. Nomads develop aggregated forms of social groups working on different social principles from sedentary societies. They're not so centralized, they're not so oriented around work or the state. These less systematically stratified groups can become war machines. That's discussed in other plateaus. Perhaps I'll do another video on it. So striation is associated with settled societies, and it is of course an important technique to make scientific and technological progress. It's important to enable a lot of social development as well. Organising the land into definite areas helped the development of agriculture, definite ways to striate land. And the world being subdivided helps develop manageable closed systems. So what's the problem with striation? Well, there's one obvious political consequence, and that is social striation involves constraint, conventional lines to guide thinking, some of them not very nice, domination and control. Smooth space looks much more free and liberated by comparison. It will be a more creative conception because it permits us to go beyond convention. It allows qualitative change. If striated space enables progress, smooth space permits becoming, is the way that Deleuze and Guattari put it, and we've discussed becoming in another video. However, we are warned right at the end not to assume that smooth spaces can guarantee free movement, because they're always likely to be colonized and striated again. Well, given the mixed nature of most actual examples, we are going to need some general principle to describe pure, smooth space that has no actual or concrete elements. So here we are doing philosophy. What model best describes space is a question only philosophers really want to ask. Is it a regular container, as in classical notions with 3 dimensions and objects with regular shapes like triangles and cubes? Well, as we'll see, there are now newer models of space and newer geometries instead. If you like pop science programs like I do, you might even have come across models that are even newer than those admired by Deleuze and Guattari, thinking of space as a series of multidimensional strings or membranes or bundles of twisted fibres and so on. Let's get back to A Thousand Plateaus. We have here several models on offer. Technological models, mostly concerning textiles, strangely enough, musical models, avant-garde music, especially in Deleuze, I'm anglicising of course. Maritime models, the sea is a smooth space, and this includes discussion about cities and urban nomads. A lot of the heavy lifting is done with mathematical models, the important work of Riemann and others on the multiplicity, and some more recent work on fractals. There are physical models of physics, critiques of various attempts to metricate and regularise things fully, and the discussion here turns on objects like things in nature, planetary orbits for example, and work. We learn again about the difference between quantitative and qualitative multiplicities. Finally, there is a gripping discussion of aesthetics on nomad art, and whether it really is an abstract form that depicts smooth space. As you might have gathered, some of this discussion is unfortunately fairly obscure, and we imagine that what happened was Deleuze and Guattari once attended a high-powered Parisian salon and met all sorts of art historians and mathematicians, and this plateau is a kind of echo of that discussion. Okay, with all that in mind, let's start. The technology model discusses textiles, as I say, which might seem a bit odd at first, although textiles are really quite important. The gloss here is that textiles arise from attempts to striate strands, literally to weave strands together to produce a solid piece of cloth, a supple solid in this case. That's not the only way to produce cloth, and the good old nomads, much admired elsewhere, use felting techniques instead, compressing fibres together rather than weaving them. Other methods of producing textiles are also briefly discussed and compared. There is, for example, knitting with its horizontal and vertical dimensions compared to crochet, where the material emerges from a centre and I quote, draws an open space in all directions. Now, you obviously will realise that producing textiles is a very important stage in human technology, so it's worth discussing. And a particularly interesting example, which they touch on briefly, is quilting, which is quite often a collective activity pursued by women. And it also gives you interesting materials, mixed types of fabric. For example, there might be woven cloth covers filled with a looser material like down or kapok. There are also different procedures to quilt, different types of construction. We might join together themed patterns of octagons or some other regular shape, or we might decide to pursue a relatively unconstrained patchwork. The notion of the patchwork is going to appear later on. What we seem to have here is some general connection between types of social order and types of textile, hinting, if you like, at a more general sociology of technology. We're told, not really very fully, that weaving connects with major forms of science and early forms of politics as an early demonstration of the power of striation. Now, at this point, we thought of the early connection in Britain between automated jacquard looms and early computing, both systems use punch cards to convey information, and there's a link to a website on the transcript if you want to follow that one up. Generally, this sociological approach is fairly unexplored here, and it's rather simple. Mostly we're referred to other commentaries. Unfortunately, sometimes they're in French. It's pursued rather better and in connection with a Marxist framework in discussions of the work on physical models.
Music. Contemporary music can be seen as working in smooth spaces. Conventionally, music is constrained by using accepted scales and rhythms or time signatures. Musical scores depict the organisation of these sounds. We have a series of lines and spaces between them. There are symbols in various shapes to show pitch and time values. We use a very limited set of available sounds, of course. Experiments soon developed to use other sounds, and eventually definitely discordant ones, very unfamiliar chords and rhythms. Boulez is the example here with his use of different scales that do not stick to the conventional octaves. His scores show distributions of notes, like spirals instead of rigorous sequences. He offers guidelines to the orchestra rather than strict instructions. A whole musical texture can be created without fixed and homogeneous values. Page 527. A particular innovation, much admired and used as a metaphor, is the diagonal line. This connects two musical sections rather than a conventional sequence like a chord progression. It is usually played as an emphatic musical slide, as a website on Boulez tells us.
Let's look at maritime models now. The sea is a classic smooth space, of course, although modern navigation has tried to striate it by drawing up things like lines of latitude and longitude, maritime charts, and so on. That attempt is a general tendency, we're told. Modernity and capitalism always tries to striate space in order to manage and control it. However, some smoothness still persists, because the points of arrival and departure are the important things with sea voyages. The lines only suggest routes between them, and of course actual routes are unlikely to follow the lines on the chart precisely. In smooth space generally, lines where they exist are like this. They're vectors. They are not things, dimensions, that tightly prescribe a route or a measurable distance. Travel on the sea is always haptic, and this is a term that crops up later as well as something found in Nomad art. The point is that haptic events engage more senses than just vision. In other words, they generate other affects. In this case, of course, if you voyage on the sea, you'll know what this is like, a sense of motion or touch. The sea is a space with potentials to produce a number of affects, and generally it's a good example of what they call, and I quote, spatium instead of extensio. That is, a space filled with potentials rather than one with fixed dimensions. If you've heard this phrase before or come across it, you'll know that that description is also used to point out the characteristics of the body without organs. And the BWO is explicitly cited here as a comparison. We get the usual important political warnings, reminding us that the smooth nature of the seas has also been weaponized in the form of the modern submarine, which also follows unpredictable vectors, and that makes detection far more difficult. So here the smooth characteristics are only for, and I quote, the purpose of controlling striated space more completely, and they mean here striated space like national territories. This warning serves to remind us that smooth and striated spaces can change into each other, and that we're looking at actual examples, we're going to find they're impure, and we're only able to use relative terms. The sea is less striated than the land. As a further example, cities are striated, at least more than towns are, one of those relative comparisons again, but we can still stroll around them to some extent, cheerfully ignoring signposts to preferred routes. We can be urban nomads. There's a lot of discussion of this in sociology. We use this idea of a wandering path off the beaten track as an example of a rhizomatic path in the second video, and again the rhizome is explicitly mentioned here. At this point it might be an idea to pause and consider if any of the qualities of smooth space are starting to emerge for you. We have things like the avoidance of lines as determining structures, or at least the subordination of lines to points. We have vectors, directions of movement, rather than metricated dimensions, and these vectors follow different intensities. We have haptic affects, not just visual representations, and these are going to pop up later. We already know that empirical examples are mixed, and that there can be a common tendency to colonize smooth spaces by forms of metric striation especially. However, there are also some ways to smooth out striated space too. Smooth space has a potential to go either way. The remaining models move to more explicit theoretical modelling, and we've left the mathematical one to the end because it's probably the most sort of systematic. The actual examples appear in a different order in the book. We've also arranged them according to how difficult and obscure we found them. Nomad aesthetics, things like painting and drawing especially, can be understood by referring them to the notion of smooth space. Again, this section talks about the importance of nomads generally and goes along with other remarks about the positive nature of nomad culture. Nomads, for example, do not take up notions of normal clock-regulated work, but that's not because they're inherently lazy. Instead, they want to reject regimented work for fully understandable positive reasons. Similarly, they're quite capable of thinking of a modern political system and state, but they don't want to establish one. They prefer to remain with the local powers. So here the issue is how to understand their paintings and drawings, again, which are often seen as primitive or early or not very sophisticated. Should we see them as simple depictions before the great developments of realist representation and perspectival art in the European Renaissance? Or should we see them as something more positive, an attempt to depict abstract or smooth space? Well, we can certainly see some modern abstract art like that, which is how Deleuze sees Francis Bacon in his book, given the reference to that on the transcript. Some earlier examples might fit too, and Deleuze and Guattari cite examples like what they call, and I quote, the Northern Gothic line. I actually don't think it's their term. And what this means is those elaborate patterns and interwoven lines associated with the Goths. I don't mean the people who dress up in black in subcultures. And later on the Celts. We live on the edge of Cornwall, so you can see a lot of Celtic art around in Cornwall. Again, these elaborate interwoven lines. A big debate about nomadic art then ensues. And here we are discussing the work of two particular art historians, Warringer, I've anglicised, probably Warringer, and Regal. Well, non-experts must find it hard to contribute here, we certainly do, but according to the Wikipedia entries at least, both of these theorists believed that there was a constant and universal human interest in abstract space. So we have a positive take again on so-called primitive art. Nomadic artists could have reproduced conventional lines, but they wanted to avoid them. Instead, nomadic art is, and I quote, positively motivated by the smooth space it draws. And what we find in nomadic art is, and I quote again, the affect of smooth spaces, not a feeling of anxiety that calls forth striation. Now, Deleuze and Guattari have some reservations about these arguments, but they basically agree. So, using terms that appear later as well, nomadic art shows us and I quote, a nomadic absolute, a local integration moving from part to part and constituting smooth space in an infinite succession of linkages and changes in direction. Still quoting, it is an absolute that is one with becoming itself, with process. End of quote. So nomadic art does not have a fixed plan, but it kind of joins things up as it goes along, again, like a patchwork. It's not governed by purely optical conventions like perspective. It is instead haptic. For people who like it, it generates a sense of touch. We feel we are in touch with it, quite literally. It invites a close-up look, not a distant, more unemotional one. It's not centred on conventional human subjects. When it does depict humans, Deleuze and Guattari say it's unconfined by conventional notions of organism. It represents life, which organisms only solidify. And I quote again, a powerful life without organs, a body that is all the more alive for having no organs. And this is clearly a deliberate reference back to the body without organs.
We took the section on physical models next. The argument is that space and solid objects cannot be striated with simple straight lines and are not easily measured by standard metric scales. Eventually, this will mean that space is not describable in terms of fixed quantities combining in various arithmetical ways. Space is not adequately represented in formulae or standard equations. Smooth space offers a better account instead. It is, and I quote, a continuous variation that exceeds any regular distribution of constants and variables, the freeing of a line that does not pass between 2 points, the formation of a plane that does not proceed by parallel and perpendicular lines. In one example, Newton managed to depict the orbit of the planets according to equations derived from his laws of motion. Gravity was a constant universal force, but the model is okay only for 2 bodies. 3 bodies produce inherent unpredictable variations. There is a bending of regular lines that become tangents around other bodies. Some stability can be restored in the form of spiral paths. Between the regular lines and the spiral lies smooth space, or maybe chaos according to some definitions. We can make predictions only in the form of probabilities there. The Greeks were onto this too, apparently providing alternative notions of space to the familiar one developed by Euclid. Deleuze and Guattari note that there are many common examples where it is impossible to strictly metricate the variables. Sound is one of their examples. Sounds vary in terms of their intensity and frequency, but they cannot just be added together. The intensities of sound are qualitative differences. Thinking of our own examples, awarding grades for essays is a qualitative matter too. It is not simply the case that an essay grade of 70 is somehow twice as good as an essay grade of 35. Of course, assessors then employ what is really an illicit procedure. They pretend that these numbers are proper quantities so that we can then add grades, average them, and so on. Deleuze and Guattari notice that this tendency is a common one. Metrication is imposed to manage complexity. Certainly, if you abandon metrication, you are left with measures and scales that are far less precise and exact. With ordinary scales, you only can say that one thing is larger than another, without specifying how great. Deleuze and Guattari use the term unexact for these measurements, not exact in metric terms, but still rigorous. One particularly interesting section deals with attempts to quantify, measure and evaluate human work. A physical conception of work as a matter of weights, heights, forces and displacements became allied to a socio-economic concept of labour power or abstract labour. This was something homogeneous and abstract which could be applied to all work and which could be metricated. As a result, every human activity could be translated into work. Free action could be disciplined, or at least relegated to mere leisure defined against work. This work model became a fundamental part of the state apparatuses. The concept of labour that developed was always associated with surplus and stockpiling and the disciplining of free action, the nullification of smooth spaces. What we lost was the continuous variation of free action, passing from action to song to speech to enterprise. There is the usual warning. Capitalist calculation no longer requires just calculating quantities of labour, but is more complex and qualitative. It now extends to infrastructure, the media, every semiotic system, page 543. In this, capitalism has reconstituted a sort of smooth space. The multinationals produce this deterritorialised smooth space, breaking with the classical striations. So the real struggle these days is between striated capital, still tied to territories like nation-states, and smooth capital, able to operate across these boundaries. New political forms might be able to reverse colonisation and create more liberating smooth spaces. Guattari's politics explore these possibilities best, with his interest in Italian autonomism or various anarchic cultural and political ventures like French free radio.
The mathematical model is the final one, and it begins with the work of Riemann on the multiplicity. Riemann's had quite an influence on the work of Deleuze, apparently, and I've included a couple of quite readable articles on this link on the transcript. To simplify a great deal, Riemann was interested in trying to imagine and define what a multidimensional space would look like, and for various reasons he eventually came to think of it in terms of a number of more recognizable spaces folded together in complex ways. Well, one helpful analogy, which I found on a website, I've referenced it on the transcript, suggests that you take an ordinary flat sheet of paper and then crumple it in your hand. The resulting object would give some idea of what Riemann meant by an n-dimensional space, although obviously it's still in 3 dimensions. It is a many-folded structure, a manifold, or to use another term that is a translation of the original French, a multiplicity. The analogy is helpful in another way as well, in that you can see that the crumpled sheet of paper features lots of smaller conventional spaces, 2-dimensional polygons, joined together in diverse ways, like a sort of 3-dimensional patchwork, to revert to that analogy. And apparently this was another argument developed by Riemann, that there is no overall structure for space. It is rather a patchwork of local spaces joined together by local relations, producing something that's infinitely complex and spreading over n dimensions. It's also clear there are no simple linear relations between points on the local spaces. Put a point on some of these local spaces if you like, and try to explain the connections between them. Well, we'd obviously have to talk about lines, curves, angles, altering distances and directions, and instead you might like to think of connections which involve terms like intensity or frequency. These are qualities, none of them really metric. And to pursue this simplistic analogy for a moment, space itself contains potential forces or vectors, and these have been actualized or made concrete in the local spaces that are joined together. Now, of course, you have supplied those forces from the outside by crumpling the paper, but space itself contains those forces internally. We can follow the process of non-metricated intensive forces taking actual forms as a result of some simple basic operators at work, and this is Riemannian geometry. What they do are things like bend, stretch or deform space. And apparently these are indeed the only forces we can specify in the geometry or topology of n-dimensional space. We've left the 3D dimensions far behind. As usual, I find that Delander's book, Delander 2002, especially chapter 1, offers the best description of this sort of argument and talks about how further operations are possible, including ones that reduce symmetry, and if you apply them, you eventually end up with the familiar solid three-dimensional bodies that we know in the space around us. All sorts of implications follow. Deleuze and Guattari can't resist one that involves the apparent end of dialectical reasoning, and this is a technique employed by philosophers they don't really like. Classically, the argument is that forces and tendencies come together only in opposing pairs, and that these interact and produce some third term. Once we think of multiplicities, we don't just have opposing pairs, but a multiplicity of forces and tendencies, and they can interact in all sorts of ways, not just by opposing each other. There's also a reference back to the discussion on Bergson. Now, we have discussed him a bit in the videos on image in film. What he did was to insist that time and space are far more complex than the basic scientific definitions suggest. Both have qualitative dimensions as well. Now we can see this at its clearest if we just consider the human notion of duration. For example, as we get older, we accumulate years, standard measures of time. Time passes. But in the process, there are qualitative changes. We change from childhood to old age. So it's not just a quantitative matter. When we consider space, well, we might refer back to those famous dilemmas in describing motion, and Deleuze and Guattari like to revisit the ancient Greek paradoxes discussed by Zeno. Bergson does. But the best example is that the motion of a horse also involves qualitative change. As it gets faster, it's not just a quantitative increase in velocity that we observe, but a qualitative change from walk to trot to canter to gallop. Well, there's also a nice aside on number as well, which refers back to the discussion we've had on ordinals. These also express a sense of number before number was fully metricated. It's almost an original notion of number. And of course we still use them. Some of the other explorations of complex space undertaken by mathematicians are perhaps more popular. Fractals, for example, have appeared in popular culture, and they're actually discussed in a way that's almost clear and reasonable in this plateau. The argument is that the length of a fractal line cannot be established definitively because it's not just a straight line, it keeps branching off to enclose extra shapes, triangles in the case they discuss. If we examine fractal lines from far away, they look like simple straight lines, but as we get closer in, they have more dimensions, more lines. As a result, they are not just normal straight lines with a straightforward connection between 2 points. That would have a dimension of 1, but they don't exactly occupy a regular surface either, a two-dimensional flat space. As a result, they can only really be represented by a fraction or a decimal between 1 and 2. Fractional fractal. The plateau discusses other equally odd objects like Sierpinski sponges. These are sponges which have holes drilled in them. They have a cubic shape, but they have holes drilled into them, an infinite number of holes again. As a result, they have a different ratio between surface area and volume from the conventional cube. They lack a volume that they, if you like, should have, but they're not just surfaces either, and so the way to describe them again is a fraction that is more than a surface but less than a volume. Now again, if you struggle like me with this, there's quite a helpful explanation of the Sierpinski triangle, at least on a website that I've referenced on the transcript. Well, after this intriguing discussion of mathematical models and objects, we finally get something like a list of definitions of smooth space as opposed to striated. And I think we've covered them really, but let's go through them just to be formal. First, a striated or metric aggregate has a whole number of dimensions and constant directions. However, 2. A non-metric or smooth space involves, and I quote, the construction of a line with a fractional number of dimensions greater than 1. That's a fractal. Or, and I quote again, a surface with a fractional number of dimensions greater than 2. Third, the fractional dimensions indicate, and I quote again, a properly directional space with continuous variation in direction. 4. A smooth space therefore has dimensions lower than any conventional space, and I quote, which moves through it or is inscribed in it. In this sense it is a flat multiplicity. For example, a line that fills a plane without ceasing to be a line. Again, think of the fractal line. 5. Smooth space tends to be identified with that which occupies it with the same power, with the same, and I quote again, inexact, yet rigorous form of the numbering. 6. A smooth space of this kind can be seen as, quote again, an accumulation of proximities, end of quote, constituting zones of indiscernibility. Now I've discussed what an indiscernible is on the transcript. Again, it's a mathematical term which refers to objects which are identical and yet which are distinct. It's all gripping stuff. What we have with these indiscernibles is a notion of becoming again. They have the same sort of properties in a way, and yet they are different. To be even more simple, we have here a mathematical conception of what we've been calling a patchwork. Okay, let's round off with the overall implications, which are both theoretical and political, although they're both interwoven as usual. Let's take some theoretical implications first. We are told there is no need to multiply models in different areas, and that's because the distinction between smooth and striated space probably summarizes all the others. It turns on the idea that there are different kinds of multiplicities, and they helpfully list these different kinds that they've been discussing throughout the book. Quotes, metric and non-metric, extensive and qualitative, centered and acentered, arborescent and rhizomatic, numerical and flat, dimensional and directional, of masses and of packs, of magnitude and of distance, of breaks and of frequency, striated and smooth. End of quote. That's page 534. Well, you can go back and trace these differences in much of the specific discussion that takes place in the various plateaux. We haven't mentioned all of them, but the differences between packs and organised groups quite important to Plateau 2, which is about Freud's case study of the Wolfman. We mentioned rhizomes and trees. We mentioned bodies without organs and actual bodies. We haven't yet discussed war machines and states, but that's implied in some of those distinctions as well. Finally, how do we focus on smooth space? It's very complex and difficult to pin down, and the way we proceed is to cut through smooth space, so to speak, in order to simplify and organise our investigations. Let's be nice and literal here. Take your crumpled sheet of paper and a pair of scissors and cut through it. What you have is a flat surface, and this is a plane. The plane is a common term in Deleuze and Guattari. As we know, there are planes of immanence and planes of consistency, and what this plane will do is offer a basic way for philosophy to begin to grasp the intricacies. Some of those are displayed on the plane. Okay, political implications to round up with then. For me, the argument is about whether politics should focus on the basics, not just the apparently important surface issues like multiple identities or different models of division and solidarity. Now, Marxists have been arguing this for years, saying that class divisions are the most fundamental. But for Deleuze and Guattari, the fundamental issue seems to be this notion of space and constraint. Well, as usual, we end with some political warnings as well. We mentioned them throughout. Smooth spaces offer no guarantee of freedom because they're always liable to striation again by powerful political groups. So the political struggle will be to keep space smooth and to oppose these striations.